Volcanic activity is on the rise all over the world, and there have been violent eruptions across the globe. How great is the threat posed by supervolcanoes to human civilization? We're going to take a closer look at this, so stick around until the end. Welcome everyone. Before we get started, let's raise awareness about volcanoes by trying to get this video to reach 5,000 likes. That way, YouTube will show it to even more people. Thanks a lot, everyone. Iceland, Indonesia, Italy. Volcanoes are really erupting all over the world right now, and I find this topic both terrifying and fascinating. I was on Stromboli last year, north of Sicily, and right there the volcano was having a really active day. It was rumbling the whole time, and you could see explosive plumes of smoke. Check this out. I highly recommend a trip to Stromboli. It's a super active volcano and very easy to get to. And while you're there, you should also visit the island of Volcano, where you can hike right up to the crater's rim. Compared to some of the magma monsters currently erupting, those Stromboli and Volcano are volcanic lightweights. Let's start with the mother of all eruptions to have a point of comparison for today's eruptions. This eruption likely even brought humanity to the brink of extinction. Volcanoes are among the most fascinating formations our planet has to offer. Molten rock, gases, and particles from the Earth's interior reach the surface, but all these volcanoes are nothing more than tiny steaming incense burners compared to so-called supervolcanoes. This is a term used to describe volcanoes capable of releasing enormous amounts of lava and ash during an eruption, which have the potential to have far-reaching effects on the global climate and the environment. Unlike most conventional volcanoes, supervolcanoes are characterized by their exceptionally large caldras, a type of crater formed by the collapse of an emptied magma chamber. A famous example of a supervolcano is Yellowstone in the US or the Phlegraean fields near Naples in southern Italy. An eruption of such a supervolcano would have catastrophic consequences for the local and global ecosystem. The release of large amounts of volcanic ash into the atmosphere could lead to significant climate effects, including global cooling. Such events are, however, very rare and fortunately occur only once every few 100,000 years. Another supervolcano is the Toba volcano on Sumatra, whose eruption changed the world 500,000 years ago. The eruption from over 70,000 years ago is considered the largest eruption on Earth in the last 2 million years. Compared to that, the recent eruption of Mount Etna was just a minor earthly belch. Researchers estimate that the Toba eruption hurled approximately 2,800 cubic kilometers of volcanic material into the air and released up to 2,000 megatons of sulfur dioxide into the stratosphere. To give you an idea of how much volume 2,800 cubic kilometers represents, take a look at Lake Constance, which holds just 48 cubic kilometers. So we would need about 58 Lake Constances to match the amount of material that the Toba volcano ejected into the atmosphere back then. And this amount of material formed a kind of veil in the atmosphere through which sunlight could no longer shine freely. As a result, less sunlight and heat reached Earth, causing the global climate to cool by up to 3.5 degrees for several years and ushering in a volcanic winter. The cooling of a few degrees back then was not the reason why the entire species nearly went extinct. There were other factors at play that were far more dramatic than the cooling. One truly devastating consequence for the environment and life concerned the ozone layer. Sergei Osipov from the Max Planck Institute for Chemistry in Mainz and his colleagues have discovered how the eruption of a supervolcano might have affected our ozone layer. The ozone layer is a region in the Earth's atmosphere that contains ozone in higher concentrations than other parts of the atmosphere. It extends from about 10 to 50 kilometers above the Earth's surface in the stratosphere. This layer plays a crucial role in protecting life on Earth by absorbing a large portion of the sun's harmful ultraviolet radiation. So the ozone layer is basically like sunscreen for the Earth's skin. In any case, the ozone layer absorbs most of the sun's shortwave UV radiation, particularly the dangerous UVB and UVC rays. This prevents this radiation from reaching the Earth's surface, which is crucial for life on Earth. UV radiation can cause skin cancer and other health problems in humans, as well as harm to animals and plants, and the ozone layer, acting as a protective barrier, helps minimize these risks. However, during a massive volcanic eruption, a small problem arises in these layers, as Osipov explains. To produce ozone from the oxygen in the atmosphere, photons must break the O2 bond, but when a volcano releases large amounts of sulfur dioxide, this eruption cloud blocks sunlight. This impairs ozone formation, creates an ozone hole, and increases UV exposure. The researchers wanted to know what the ozone layer might have looked like after the Toba catastrophe and used an Earth system model from the Goddard Institute for Space Studies to investigate how severely the eruption might have damaged the ozone layer. As mentioned, it was assumed that around 2,000 megatons of sulfur dioxide were emitted and propelled into the stratosphere, where they then spread primarily around the tropical belt. The result? The aerosol veil in the atmosphere was so dense that ozone levels were reduced by 20%. It is even believed that the ozone layer in the stratosphere may have collapsed in the tropical regions. Osipov says, "Our calculations indicate that the ozone layer near the equator dropped to less than 125 Dobson units. That corresponds to a reduction of more than half. Specifically, this means that an ozone hole could have formed over the tropics at that time, one that is in no way comparable to today's ozone hole. The main cause of an ozone hole lies in the release of chemical compounds such as chlorine and bromine compounds, which originate from human activity because they are used in industrial processes or in products like refrigerators, or indeed through volcanic eruptions. However, the ozone depletion caused by the Toba eruption, or the ozone hole at that time, must have had truly serious consequences for people because UV exposure increased enormously. Researchers estimate that it rose by 140% to a UV index of around 28. A normal value is between 5 and 8. It is very likely that people at that time would have developed damaged or inflamed eyes after spending even a short time outdoors, or suffered skin rashes from sunburn and inflammation. These high levels of radiation exposure must have led to an increased risk of cancer and also weakened the immune systems. Researchers believe that these altered environmental conditions must have caused the human population in the affected areas to decline sharply. Incidentally, the Toba volcano is still considered active today, but it shows no signs of an imminent eruption. Volcanologists, of course, monitor such volcanoes closely to detect changes in their activity and develop early warning systems in case activity should increase. Nevertheless, one might ask, what if the Toba volcano were to erupt again today? That would have significant impacts on the environment and global civilization. A volcanic winter would set in once more, with severe consequences for our agriculture and food supply. Areas on Earth are much more densely populated today than they were over 70,000 years ago. Such an eruption would therefore claim countless lives and damage existing infrastructure for decades. Furthermore, the volcano could also cause long-term ecological changes, including loss of biodiversity, changes in the ecosystem, and potential impacts on the oceans. And just last year, we also saw volcanic activity in the Toba region, specifically in Indonesia. Mount Ruang erupted, entire islands were evacuated, and the situation remained out of control for a long time. And the images of this eruption are simply incredible. Among other things, we see what's known as a volcanic thunderstorm. Let's take a look at that. Mount Ruang on the island of the same name has absolutely exploded. I don't think there's any other way to put it. Ruang Island is part of the Sangihe archipelago north of Sulawesi. The active stratovolcano there rises 725 meters above sea level and is known for its explosive activity, which has long made it a massive geological hazard in the region. Ruang is one of more than 120 active volcanoes in Indonesia, a country located on the Pacific Ring of Fire, a zone with some of the most frequent earthquakes and volcanic eruptions in the world. 90% of all global earthquakes originate in this zone along the Pacific Ring of Fire. Ruang is a stratovolcano, and these are typically known for their steep sides and cone-shaped structure, which is formed by the accumulation of lava, ash, and other volcanic material ejected during eruptions. The lava that flows from stratovolcanoes like Ruang is usually viscous and moves slowly. This is, of course, generally an advantage for local residents when it comes to evacuation. We'll get to that in a moment. The lava cools quickly and then hardens into sharp-edged formations that make up the characteristic terrain of this type of volcano. And the composition of the magma is rich in silicon dioxide, which leads to a high degree of viscosity and puts pressure on the gas bubbles within the magma, but this also leads to a buildup of pressure, resulting in highly explosive eruptions in which large quantities of volcanic material are hurled into the atmosphere, creating pyroclastic flows that are feared for both their heat and their destructive power. One of Ruang's most violent eruptions occurred in 1871. This violent eruption caused part of the volcano to collapse into the sea, triggering a devastating tsunami. The 1871 tsunami claimed 400 lives and left a trail of destruction on the neighboring islands. This historic eruption is a clear example of Ruang's destructive power. In addition to major eruptions, Ruang has also repeatedly experienced a series of smaller eruptions. These smaller eruptions were often accompanied by ash emissions that impaired air quality and caused health problems for residents. And one might think that because of these events, the locals harbor a certain aversion to the volcano. But for the people on and around Ruang, the volcano holds deep spiritual significance. It is seen as a powerful force of nature that commands respect and awe. Many legends and myths revolve around the volcano's power, and this deep-rooted reverence that people have for it is somehow impressive. It reminds me a bit of the relationship the people of Naples have with Vesuvius. For them, Vesuvius and the Campi Flegrei are somehow part of life, despite their destructive potential. After a period of relative calm, Mount Ruang erupted in a series of eruptions. Check out this incredible footage here. I think the volcano's power really comes through clearly. This activity prompted Indonesian authorities to declare the highest alert level and initiate extensive evacuation measures. The volcano began its active phase late in the evening when it suddenly spewed ash clouds and glowing lava several thousand meters into the air. Here we see satellite images from the Cooperative Institute for Research in the Atmosphere. We can see ash and sulfur dioxide rising thousands of meters into the atmosphere due to the explosive eruption. Over the first few hours following the initial activity, the eruptions intensified and at least 5 major eruptions were recorded. For the Indonesian Agency for Volcanology and Geological Hazard Mitigation, it was immediately clear highest danger level and evacuation. The eruptions produced gigantic ash columns reaching up to 3,000 meters into the sky and triggered pyroclastic flows, a deadly mixture of hot gases, ash, and volcanic rock that raced down the volcano's slopes at high speed. These flows are particularly dangerous because they can burn and destroy everything in their path. And due to the severity of the eruption and the potential risks of a volcanic collapse into the sea, which, as in the past, could trigger a tsunami, the 800 residents of Ruang were evacuated. But it quickly became clear that we were indeed dealing with a phase of intense activity and that evacuations would need to be expanded to a much larger area. In the end, about 12,000 people had to be evacuated. This is because, due to ash clouds and the risk of a tsunami, the danger zone extends not only to Ruang itself, but also to a vast island region surrounding it. The whole situation is somewhat reminiscent of the eruption of the Krakatoa volcano in 2018. At that time, the Anak Krakatau volcano, also in Indonesia, erupted violently, causing a significant portion of its crater to collapse into the sea. Over 400 people lost their lives, thousands were injured, and coastal settlements and infrastructure were severely damaged. Even eruptions in Indonesia that are not as far-reaching, that is, those without a tsunami, are often deadly, by the way. In December 2023, the bodies of 11 hikers were found on the slopes of Mount Merapi on Sumatra after an eruption spewed an ash column nearly 3 kilometers into the air. A distinctive feature of such ash columns is what are known as eruption thunderstorms. During a volcanic eruption, enormous quantities of ash, dust, and other particles are hurled into the atmosphere with great force. As these particles rise, they collide and rub against one another. This friction generates static electricity similar to thunderclouds, where, for example, ice particles rub against one another. This accumulation of static charge in the ash cloud leads to strong electric fields. When the electric field becomes strong enough, it discharges in the form of lightning. In addition, the intense heat and the release of gases such as sulfur dioxide during a volcanic eruption ionize the surrounding air, thereby energizing it. Ionized air conducts electricity better and can thus serve as a medium for these discharges. And it is very likely that what we see here in the Ruang image is such an eruption storm. In addition to all the volcanoes that are currently erupting, there are also giants that are dormant but still active. And if they decide to erupt, it will be apocalyptic. The best known is probably Yellowstone, but few people know that the US has another supervolcano, the Long Valley Caldera, and it's currently showing signs of activity, which is causing some concern among volcanologists. The Long Valley Caldera is located in eastern California. On the surface, It consists of an imposing crater east of the Sierra Nevada, hence the name, as a caldera refers to a circular depression formed by volcanic activity. And the Long Valley caldera is the second largest caldera in the United States after Yellowstone, making it one of the largest calderas on Earth. This current caldera and its distinctive landscape were formed by a massive eruption 760,000 years ago. At that time, 1,400 cubic kilometers of ash, pyroclastic material, and lava were ejected. This led to a massive ash deposit that covered large parts of eastern California and reached as far as Nebraska. This eruption created a depression measuring 540 square kilometers, which is 300 to 1,000 meters lower than the surrounding region. This gives a rough idea of just how apocalyptic this eruption must have been. Unfortunately, it now appears that another eruption may be imminent. The U.S. Geological Survey operates its own observatory, the Long Valley Observatory (LVO), to monitor the caldera's activity. For a long time, it was assumed that the supervolcano had entered a long period of dormancy and that there was no real danger. But over the past few decades, geological conditions have changed. Seismic activity has gradually increased, and in recent years, the situation has taken on alarming proportions. Geophysicist Ashton Flinders of the U.S. Geological Survey says, "Our data suggests that there have been significant magma inflows since the last eruption 760,000 years ago. This means that the supervolcano may not be as dormant as previously thought. Given how massive the eruption 760,000 years ago was, it's clear that another eruption of this magnitude would have global consequences due to the release of ash. The southwestern United States would, of course, be hardest hit, but air traffic would also grind to a halt globally, and it could even lead to climate changes." Geophysicist Birger Gottfried Luhr from the German Research Center for Geosciences agrees, stating, "If the eruption is on a similar scale to the one 760,000 years ago, we must expect global consequences." So is an eruption on the horizon, or could there be other causes? A research team led by the aforementioned geophysicist Ashton Flinders has taken a very close look at this. They see two possible processes inside the volcano as potential causes for the recent uplift of the Earth's surface. Possibility 1. The liquid magma is nearing complete solidification. This would be accompanied by the expansion of the cooling rock, thereby raising the Earth's surface. So that would be the optimistic scenario. According to this, we're just witnessing the volcano's slow settling down, and an eruption would be unlikely, but then, unfortunately, there's also possibility 2. Pressure is building up inside due to gas and liquid magma that can't escape. This pressure could be released in an eruption. Unfortunately, option 2 is the more likely one. The research paper states, "Although we cannot distinguish between magmatic intrusion and the mobilization of exhaust fluids as the driving force behind the recent uplift at Long Valley, we can conclude that the mid-crustal reservoir is still rich in melt." Geologists tend to use complicated language. What this means is that while the cause of the recent seismic activity could not be determined, it has been established that there is indeed still plenty of magma bubbling inside the volcanic system. There is no sign of inactivity or a dormant phase. We estimate that the reservoir currently contains enough magma to support another supervolcanic eruption, comparable in size to the caldera-forming eruption 760,000. So the volcano remains active, contains a great deal of magma, and the total volume of this volcanic material is also large enough to cause an apocalyptic eruption. Of course, that doesn't mean a major eruption is right around the corner. To better assess the danger, many other factors would need to be examined more closely. Further drilling is planned to determine whether the molten magma is concentrated in a single large reservoir or distributed across several smaller ones. An eruption also depends on whether the reservoir continues to be fed by new magma inflows from the Earth's interior. Near the Long Valley caldera, there are other extremely young lava fields along the nearby Mono Inyo crater chain. So completely independent of the activity of the Long Valley caldera itself, there are other magma chambers in the area, and these alone are active enough to cause, for example, strong earthquake swarms. Consequently, the entire Long Valley caldera region is classified as a very high threat by the U.S. Geological Survey, but there is also danger from supervolcanoes in Europe, for example the Phlegraean fields west of Naples. 40,000 years ago, this supervolcano already changed the climate of the entire continent, and now it is rumbling beneath southern Italy again. For the past 2 years, there have been several earthquakes. The cause of these earthquakes is not only the Phlegraean fields, but primarily Mount Vesuvius. According to the INGV, the epicenters are being recorded on the slopes of the volcano in a densely populated area not far east of Naples, at a depth of 2.9 kilometers. The magnitude of these earthquakes alone is not yet cause for alarm, but the fact that Vesuvius is now becoming increasingly active is cause for concern. Naples lies exactly between Vesuvius and the Phlegraean fields. The city is thus now flanked on both sides by volcanic systems that are becoming more active. And I was reminded once again in a very vivid way of what Vesuvius is capable of when I visited the buried city of Pompeii. The last significant eruption of Vesuvius to date occurred about 80 years ago. It began on March 18, 1944 and lasted 10 days. Despite the evacuation of more than 10,000 people, there were tragically 26 fatalities. 80 years is a long time, and many volcanologists believe that Vesuvius is overdue for an eruption. Thomas Walter from the German Research Center for Geosciences says, "The people there live on an active volcano, or rather caught between two active volcanoes. Both volcanoes are ripe for an eruption, and given this fact, the now increasing seismic activity around Vesuvius is very concerning. The Campi Flegrei area extends not only west of Naples beneath the municipality of Pozzuoli, but also beneath the sea in the Gulf of Naples. The earthquakes in the Phlegraean Fields region are triggered by a phenomenon called bradyseism. This is a very slow earthquake in which part of the surface gradually rises and subsides. Volcanologist Fabio Sansevero from the INGV had explained bradyseism to me in Pozzuoli using the ancient temple of the Serapi as an example. In fact, the temple is essentially the oldest seismic monitoring station in the world. Due to the slow ground uplift, it used to be underwater, and even today you can identify the remains of marine organisms on the columns. Over the past 100 years, there have been periodic phases of uplift. In recent months, however, the frequency of these events has fueled fears among researchers and residents of a possible eruption. After all, this increasing activity is not an everyday occurrence, and this is clearly evident in the numbers. According to the INGV, the Earth's surface has been rising by 15 millimeters per month recently. In addition, the frequency of earthquakes increased during this period. The Earth shook more than 1,500 times. Some 40,000 years ago, the supervolcano likely spewed ash and rock as far as Egypt and Russia, causing a sort of continental winter. A new study by NASA's Goddard Institute for Space Studies cast doubt on previous assumptions regarding the effects of supervolcanic eruptions on the global climate. The basic assumption regarding the influence of volcanic eruptions on the climate has always been that large amounts of sulfur gases entering the stratosphere cause a significant cooling of the climate. These gases form a veil of aerosols that reflects the sun's rays, thereby causing cooling. But how significant is this cooling? The authors of the new study examined various scenarios of super eruptions by conducting simulations with different sizes of volcanic particles, and concluded that supervolcanoes may not be capable of influencing the climate as strongly as we previously thought. They estimate the potential cooling at a maximum of 1.5 degrees, and in some cases warming could even occur. The cooling models published in the past vary so widely that they are virtually meaningless. The lead author of the new study, Zachary McGraw, says the comparatively modest temperature changes that we could best reconcile with the evidence might explain why no single super eruption has provided clear evidence of a global catastrophe for humans or ecosystems. So that might give us a little hope, because even though activity in the Phlegraean fields is increasing, the effects on the global climate might not be all that drastic after all. On the other hand, we want global temperatures to drop, not rise. From that perspective, it's actually pretty bad news. Well, it would probably be best if it didn't erupt at all. No quote expresses the experts' uncertainty better than this one from Carlo Doglioni, president of the INGV. There are two possible scenarios for how the situation in Campi Flegrei will develop. In the best case scenario, the ongoing bradyseismic crisis ends as it did in 1983 to 1984. In the worst case scenario, there will be an eruption similar to that of 1538. I hope you're all super volcano experts now. As soon as there are any new eruptions or volcanic developments, I'll keep you updated right away. Of course, that's only possible if you follow my channel. So everyone, be sure to hit the subscribe button, and if you've already done so, don't forget to help us reach 5,000 likes. By the way, there's also a threatening active volcano in Greece that has caused destructive tsunamis in the past and may even be responsible for the myth of Atlantis. I'm talking about Santorini, and volcanologists have found some concerning evidence there as well. You can learn all about it in the video below. As always, there's another video about science and space in the bottom right corner. Otherwise, I'd say see you in the next video. Take care, everyone.